Here we are asked to find the equation of the tangent line to the graph of y equals natural log of e to the x squared at the point -2, 4. So over here I have my graph. So they're saying at -2, 4 right here, I want to find the tangent line. So the line that touches the curve in only one spot. I want to find the equation of this line right here. Now what do I need for that line? Well, remember, back in our algebra days, y equals mx plus b is the equation of a line, where m is the slope. So I need to find the slope of this line somehow. So let's walk forward a little bit to our calculus days. How do I find the slope of something? Well, of course, I take the derivative. So if I have y equals natural log of e to the x squared, I need to take the derivative of this. But right here we have a function inside a function. What does that make you think of? Chain rule. So I need to take my inner function. We'll say u equals e to the x squared, so the chain rule. Remember, the chain rule is the derivative of the outside function evaluated at the inner function times the derivative of the inside function. That is f prime of u times u prime. So if u is this, u prime is equal to, but this is another chain rule because it is e to x squared. So the function of e and the function of x squared. This then would become, so we have to take the derivative of the outside function. Well, e to the u is still e to the u, evaluated at the inner function, so it's still e to the x squared, times the derivative of that inside function. Well, that's 2x, derivative of x squared. Okay, so that's the u prime. Now let's look at our f of u, or our outside function, is natural log of u, which then goes to f prime of u is equal to, here's the catch, the derivative of the natural log is 1 over u. Well, not much of a catch, but just one derivative that we have to remember. So 1 over u. And now, putting my chain rule together, I have dy dx, or my derivative, equals outside of function evaluated at the inner 1 over e to the x squared times 2x e to the x squared. Now this, okay, you can see these e to the x squareds and it looks pretty messy, but it cancels nicely. Look at this. We have an e to the x squared up there, e to the x squared up there. Cross them out. The derivative is just 2x. So anywhere, what that is telling me, anywhere on our curve over here, anywhere on this curve, the slope is going to equal 2x. But we are interested at the point -2, 4. Therefore, f prime of -2 is equal to 2 times -2, or -4. Or, with my notation up there, y equals mx plus b, my slope is equal to -4. At the point -2, 4, this guy right here, the slope is -4. So now I need to write the equation of the tangent line. Remembering again to our former algebra days, we have point slope form, y minus y1 equals m times x minus x sub 1, where x sub 1 and y sub 1 are our point. So if our point is -2, 4, so I can substitute in my values, and we have y minus 4 equals -4, my slope, times x minus 2, so x plus 2. So y minus 4 equals -4x minus 8. And finish out solving for y. Y equals -4x minus 4. And that, right there, ladies and gentlemen, is the tangent line, the equation of the tangent line to the slope natural log of e to the x squared at the point -2, 4.